Hello everyone. In this lesson, we will talk about derivative of implicit functions. Unlike the explicit function, in which your variable x or y has already been isolated, the implicit function contains both the x and y variables, and sometimes it's impossible to solve for any of this unknown. So let me show you the example of an implicit function before we get into other steps how to differentiate this type of function or relations. So for example, take a look at this example 1. Given x squared plus y squared equal to y to the exponent 3 minus x. So if you are trying to isolate one of this variable, such as you said, okay, I'm going to solve for x and then I differentiate in terms of x. So it doesn't matter how hard you try here, you won't be able to isolate any of this variable to leave it on the left-hand side of the equation. So in this case, we have to apply the steps to differentiate implicit function or relations. All right, so before we get into the step, I would like to remind everyone this. dy over dx is the derivative of y as a function of x, or is the derivative of y with respect to x. Okay, so I may now using this terminology as well, like derivative of y with respect to x, or I usually say that the derivative of y as a function of x. So if you have dx over dx is the derivative of x as a function of x, and is also the derivative of x with respect to x. So this is actually equal to 1. And since it's a multiplication, and you multiply by 1, most of the time we ignore this step. However, I would like to emphasize this in this particular lesson because it will help you understand why you have to multiply by the dy over dx. Okay, so dy over dx is the derivative of y with respect to x. It also represent the difference of y over the difference of x. So derivative of a function is like you are finding the slope of that function at a given point. All right, so if I ask everyone to review the terminology, then why don't we go over the terminology before we started to get into the step. The purpose of giving you this example, let's say I say y equal to x squared. Okay, so this is a very simple function. Everyone knows that it is the parabola with the vertex at the 0, 0 vertex right here. Okay, a parabola is opened up, y equal to x squared. So this is x and this is y. Okay, so if I ask everyone to take derivative of this function, then we all know that, okay, I will write dy over dx, and what is derivative of x squared? It's just 2x. All right, okay, so before I can just ask everyone to say, here's y already isolate for you, so you just write dy over dx. However, in the behind the scene of all of this notation is actually this. So it will be, you are going to take derivative of y as a function of x, okay? And then you take the derivative of x squared as a function of x. So originally, it should be written like this. However, I don't want to get everyone confused with too many notation. Also, the textbook just mentioned dy over dx or y prime. I like to explain a little bit more for everyone. Okay, so taking derivative of a function is an operation for calculus, right? So it's the very basic operation in calculus that you have to learn. So because it's an operation, whatever you do on this side of your equation, you must do the same thing on the other side. So that logic concept of mathematics still apply to the equation right here. So if I have an equation, I apply an operation on one side of the equation, I have to do the same thing on the other side. So in this case, I differentiate y. The same thing, I have to apply the differentiation on the other side of the equation. So then from here, what you have is this just, what is derivative of y? Is that 1? Okay, so it is 1. And then is dy over dx. Okay, so this one, what is derivative of x squared? Is 2x, and then times dx over dx. And what is dx over dx? It's just 1. So in this case, you see that you have 2x, you have dy over dx. This number 1, you don't have to write that, and dx over dx is just equal to 1. Okay, so this one, we do not write multiplication of 1. Okay, so when you multiply by 1, you ignore it, right? So because you end up with the same thing anyway. So then we ignore this also 1. So therefore, we just say dy over dx equal to 2x. All right, so you see the behind the step of the differentiation, behind the notation is all this. But because we simplify the process of writing and talking about derivative, so I ignore this here. Okay, I ignore this step. And then just, I taught everyone to get right into the differentiation. However, I want to remind everyone that differentiation or taking derivative is an operation in calculus. So whatever you do on one side of the equation, you do the exact same thing on the other side. All right, so I think I explained in quite lengthy for this very basic concept, because it's related directly to the step that we have to perform next. Okay, so to find derivative of an implicit function or an implicit relation, here's what we have to do. We find derivative of each term. Okay, so I just want to remind everyone that if I find derivative, I just want to remind everyone that given the function is continuous at certain points, okay, and the implicit relation, I will choose the segment where it's actually continuous. Okay, so we find the derivative of each term. Okay, so what we need to do is the first step is we find derivative of each term, and then if finding derivative in term with y, okay, then we make sure that you are multiply by the derivative by dy over dx. If you find the derivative of the term with x, then make sure you multiply by the dx over dx, and then dx over dx is just 1. So we probably will eventually ignore this step right here, but the dx over dx equal to 1, which you don't have to write, support the fact that you have to write dy over dx. Then what you do next, you move all term contains dy over dx to the left hand side of the equation, and then you move all terms without dy over dx to the other right side of the equation. So dy over dx is the unknown that you have to solve for because you find derivative, right? Okay, so then you factor, and then you solve for dy over dx. Okay, so all of this step will be clarified in the next example. So I said that we take derivative of each term, right? Because here is our function or an equation, and whatever you do on this side of the equation, you do the exact same thing on the other side. Okay, so I can write it like this. I can take derivative of x squared plus y squared as a function of x. Then I take derivative of y cubed minus x as a function of x. Okay, so because I differentiate this side, I better differentiate the other side as well. And according to the property of derivatives, okay, so let's look for that. So here it is, the property of derivatives. So I have this one right here. All right, okay. So if I differentiate sum or difference of the differentiable function of x, so what I will do is I can differentiate each one individually. Okay, so I will apply this step to my expression. So that means I would write d of x squared over dx plus derivative of y squared as a function of x. I take derivative of y to the exponent 3 with respect to x, subtract derivative of x with respect to x. Okay, so it's very logical what we are doing now. Okay, differentiate both sides because the operations, the logic of mathematics, that basic concept of equation still apply to calculus here. And then we apply the properties of differentiation. I can differentiate each of this one individually. So now you see derivative of x squared is 2x multiplied by dx over dx, which you know that is equal to 1. However, I write it here, but for my next example, I will skip the dx over dx. Alright, so here derivative of y squared is 2y, but make sure that we multiply by dy over dx. Then I have on the other side of the equation, derivative of y to the exponent 3 is 3y squared times dy over dx. Subtract what is derivative of x? It's just 1, right? And times dx over dx. Okay, so now we can ignore this and that because it's equal to 1. So this is equal to 1. Then what we need to do is we take a look at what we have in this case. So I will write it like this. So the next step is I want to move all the term contains the dy over dx over to one side of the equation. So I will write 2y times dy over dx, subtract 3y squared times dy over dx. And then on this side of the equation, I will have minus 1 minus 2x. Okay, so the next step is you want to factor your unknown. So I will factor out dy over dx in this case. So what I have left is 2y minus 3y squared and minus 1 minus 2x on the other side. So now you see that you can isolate your unknown by divide this binomial over to the other side. So now my dy over dx will be equal to minus 1 minus 2x, the whole thing divided by 2y, subtract 3y squared. Okay, so it's pretty simple if we just follow the step, okay, and we follow the rule for differentiation as well. So if you want to simplify this further, you can write it as minus 1 and 1 plus 2x, the whole thing divided by 2y, subtract 3y squared. If you want to like simplify further, or your answer like this is pretty good as well. Okay, so let me move on to the next questions. Okay, so I move on to the next one. So this is just a reminder for everyone. So if I post this note online, you know that this is just to explain to everyone why we have all the explanation here. Operation. So here is an operation. So I will put same operation, because whatever you do on this side, you do the same thing on the other side. All right, so everyone remember all the steps? So let's start it with the next example. So this one is quite complicated. Okay, so given x to the exponent 4 minus 2 x to the exponent 4 times y to the 6 plus y to the 3 equal to x minus 5x to the 3 times y. Okay, so let's take a look at example number 1 one more time before I show everyone how to work with this. Okay, so if we go back to example number 1, do you see that you just have x squared, you have y squared, you have y to the exponent 3 minus x. Okay, so you don't have any term here that you have x multiplied by y or x divided by y or anything like that. Okay, so that's why I said this example is pretty simple. But when you are working with this, you are having the x multiplied with the y, you're having the x multiplied with the y, then you have to keep in mind that you must apply product rules. Because when we differentiate and we differentiate your product, we need to apply the product rule. So there's 2 product rules that we have to work with. So it's best that we do step by step, okay? And we always write the derivative in terms of x attached to our term before we want to differentiate. Okay, so here's I write this step down, and I know that quite a few students just ignore the step, but I think it's a good idea that we should write this. Okay, so I'm going to write this as each term with respect to x. Okay, so plus derivative of y to the exponent 3 with respect to x. So it seems to be repetitive here, but honestly I find that while writing this, in my mind, I kind of analyze this function and knowing what I have to do next. Okay, so double check that, double check this, and then I want to remind everyone, this is the product rule. Okay, product rule. Okay, this is also another product rule. So product rules, I better apply to this as well. All right, so I also want to make a note that this is a negative sign. So this negative will apply to this entire product rule that I have. So let's differentiate this underneath this product rule. So when I work with product rule, I would like everyone to remember this. Okay, remember that your first term, okay, with the x is always the u. So to be safe, just attach this coefficient with this x to the exponent 4. So u equal to 2x to the exponent 4, then v equal to y to the exponent 6. Okay, so make sure that we remember this. So now du over dx is derivative of 2x to the exponent 4 will be 8 times x to the exponent 3. And then what? The dx over dx, but I will ignore that. Okay, so but let's just write that, and then everyone understand that it is equal to 1. So now I will have dv over dx will be equal to 6y to the exponent 5, but I must multiply by dy over dx. So this dy over dx is very important. Okay, so it's very important. So I have to give myself a lot more space here. So to work with the product rule, so you know that it starts with the u. Okay, so that remind ourselves of the product rule. So here's my product rule. Okay, so derivative of 2 functions as multiplication. So we should start with the u dv over dx, v du over dx. Okay, so I will write u, which is 2x to the exponent 4. dv over dx is 6y to the exponent 5, and then dy over dx. So I will put dy over dx in the bracket, and I have to add that with v, which is y to the exponent 6, multiply that with 8x to the exponent 3. So this one is done. Okay, so make sure that we do this, and don't forget is a negative sign apply to this entire bracket. Okay, then what about this product rule on this side? So then u will be equal to 5x to the exponent 3 and v equal to y. So then I will have du over dx equal to 15x raised to the exponent 2, then dx over dx, right? So dv over dx will be 1 times dy over dx. Okay, so now let's write the product rule, which is u5x to the exponent 3 times v. So dv over dx, which is dy over dx. Okay, then let me take away this. Okay, so times dy over dx. Now I'm going to add that with the derivative of u times the v. So I will write that as 15x squared times y. Okay, so this is done for this particular product rule, and don't forget it's a minus, so it will apply to this entire statement. Okay, so don't forget that it will apply to this entire thing. Then it will affect your plus sign there. That's what I mean. Alright, okay, so now let's differentiate everything accordingly. So what I have up here is I should have derivative of x to the exponent 4. Okay, so that will be 4x to the exponent 3. Okay, so 4x to the exponent 3. Now you are going to subtract this whole thing. So you are going to subtract with 2 times 6 is 12, x to the 4, y to the exponent 5, dy over dx. Okay, and then you subtract this with 8x to the exponent 3, y to the exponent 6. Okay, now, and then you add that with the derivative of this term. Okay, so this term right here, don't forget that. So I will have 3y squared times dy over dx. So on the other side of the equation, I will have 1. Okay, derivative of x in terms of x is 1 times dx over dx, so I will not write that. Now I'm going to subtract the one that I just found right here. So the one I just found right here is 5x to the exponent 3 dy over dx, and subtract that with 15x squared y. Alright, okay. Now what we are going to do is I'm going to isolate all the term. So I will bring the one with the dy over dx to this side of the equation. So I will write 3y squared dy over dx, subtract 12x to the 4 y to the exponent 5 dy over dx. Then I bring this term over, should be plus 5x to the exponent 3 dy over dx. Okay, on the other side I will have 1 subtract 4x to the exponent 3, add that with 8x to the exponent 3 y to the 6, and then subtract 15x squared y. Okay, so just want to make sure all the terms are correct. So if I solve for dy over dx, so in here I should have 3y squared minus 12x to the 4 y to the exponent 5 plus 5x to the 3. Okay, so this is the exact same thing again. Alright, okay. So now what you have to do, you just divide this whole thing over to the other side of the equation. Okay. So then my final answer will be dy over dx equal to 1 minus 4x to the exponent 3 plus 8x to the 3y to the 6 subtract 15x squared y, the whole thing divided by 3y squared minus 12x to the 4 y to the exponent 5 plus 5x to the exponent 3. Okay, so just make sure that I got all the terms correct. Alright, okay. So it seems tedious, but I think it's pretty clear of what we're supposed to do. And if we apply the correct algebra, we should be fine, right? So, but the thing I would like everyone to notice is the negative sign here. And you apply that whole negative or subtract to this entire product rule that you have. Okay, so apply this to this whole product rule that you have. Okay, so I know that it's a video lesson, so I tend to probably ask everyone, do you have any questions for me? But I know that if even though you have the question, you probably will have to send me an email. Okay, so I think everything looks good. All right, make sure that you work on the exercise that I'm asking everyone to do here. Okay, so this exercise is pretty much similar to example number 2 that I did. And I also put a negative in front of the product rule here, the negative in front of the product rule. And I have solution for this one posted online. All right, thank you everyone.